Now, today we're going to learn about Pythagoras' theorem. Now, Pythagoras was a Greek mathematician who made an amazing discovery about a relationship in right-angled triangles. Now, what is a right-angled triangle? So a right-angled triangle, how can you tell? A right-angled triangle, it has a square there, 90 degrees. So a 90-degree triangle. And first of all, you have to understand what is the hypotenuse. The hypotenuse is always the side opposite the right angle. So it's that side there, and it's the hypotenuse. It is always the longest side. So once you understand that, we can go ahead and see what Pythagoras discovered in every right-angled triangle. So what he did was he drew a square on each side. So if this side was of length A, he drew a square on it of length A. On this other side here, he drew a square, there's length B, and he drew another square on there, each side of length B. And on the hypotenuse, we'll call that C, he drew another square of length C. And what he discovered that is if he cut out this triangle, this square, and the area of the square is A squared, A times A. The area of this square is B times B, which is B squared. The area of this square here is C squared, that's C times C. Now what happens if he cut this square out and that square out, and put them into this square, they fitted exactly. Now they'd have to rearrange them a little bit and cut out bits, but they fitted exactly into that third square, the square on the hypotenuse. And so he found out that if a square is drawn on each of the three sides, then the area of the biggest square, that one, is exactly the same as the areas of the other two added together. And so this was the Pythagoras relationship. We can say C squared equals A squared plus B squared. And that's Pythagoras' theorem. Now we can write it as A squared plus B squared equals C squared, depending on what question you're doing. Okay, so the beauty of this theorem is that if you're given two sides, you can always find the third side. So you could be given A and B and find C, or you can be given A and C and find B, or you can be given B and C and find A. So as long as you know two sides, you can find the length of the third side. Okay, let's try an example. We're going to start off finding the length of the hypotenuse side. So let's say we get our ruler and we measure, and we find that this side here, it's called one of the short sides is 4 centimeters. The other short side is 3 centimeters, and we want to know what the hypotenuse is. Let's just call it x. We don't have to call it c. And so from Pythagoras' relationship, we know that x squared is equal to 4 squared plus 3 squared. Okay, now we only want to find out what x is, we don't want x squared. So if we take the square root of both sides, we find that the square root of x squared is x, and we have to do the square root of, now it's a good idea if you've got an old calculator to put brackets in there. The new calculator will bring the square root sign right along, so check that's happening, otherwise put brackets in. Now it's time to go to your calculator, and so x is equal to 5. Now it's centimeters, and so it is 5 centimeters. Now notice that this works out evenly. So if one side's 4, one side's 3, 3, 4, 5, triangle, and it's one of several combinations that work out evenly, and they're called Pythagorean triples. Pythagorean triples. So 3, 4, 5 is one example of a Pythagorean triple. Okay, let's try one with some decimals, not such even numbers. So 28.3 meters, 15.8 meters, and we want to find the hypotenuse. So once again we know that x squared equals 15.8 squared plus 28.3 squared. X must be the square root of that. It's 28.3 squared, and so on your calculator is 32.4 meters. Now it's okay to actually write your Pythagoras equation just from there. Now make sure that you round it to 1 dp because it's 1 dp in the question, and put your units.